Okay, so here we go.
We're here.
Laura
That's why I'm here.
non-existent.
Laura?
Laura doesn't
Laura?
exist.
So she's
Somebody trolling us.
Yeah. So
All right.
yeah, let's just talk through these.
Yeah. So you did a z-score. This is the equation. See?
Yeah, that's the equation for the z-score. So 0.19, you put unusual for the first one, I imagine.
So-
these are the ones I didn't get.
So I have
really?
a question. For the answers, are they just asking us to find unusual or usual, or do they want like the number and then unusual?
Yeah, they want the number.
I think you have to find out the number to find out if it's unusual or not.
Yeah, because I can show you how I got this too.
I want to see.
Yeah, I need to see.
Show me the money.
Because like this is those scores from all the different baseball teams, and then I just took the average, so finding the mean,
Sure.
and then just took the standard deviation of all these,
Sure.
and then so yeah, like I don't know why I'm 0.01 off.
So you found the standard deviation, and the standard deviation showed you what? This number?
Well, then you can calculate the z-score from that.
Okay, so
basi-
tell me how you found the z-score after standard deviation.
So basically, I'm taking the number. So this is like x in the equation,
Which is the
Which is-
standard deviation.
which is right here now. And then you take the standard deviation. So you're taking x minus the standard deviation divided by the
Mean.
actually x minus the mean divided by the standard deviation, which is right here.
Okay, so
to find
go
that
back to
number.
the equation again. So it's x. So this is the mean, and this is the standard deviation.
Yeah, so it's just value minus
The mean divided by standard deviation.
gives you z,
Mm-hmm.
which represents the number of standard deviations as a value.
And
x.
that's why you have to find the mean, not just the standard deviation, because you
So-
need the mean to plug in.
So the z-score is the number of standard deviations you are away from the mean.
Yeah.
Okay, that makes a little more sense.
I understood that. I just didn't
I have the
think to get-
definition
I
right
just
here,
didn't think
but-
to get the Excel spreadsheet to do that question. I was like, how the crap am I supposed to figure this out?
Yeah.
That makes sense.
So with the Excel spreadsheet, was that something that was like a template given, or did you put in all those numbers manually?
It's in
No.
the reading.
Yeah, it's
Oh,
it's
okay.
like one of the
So you just like
Thanks.
copy and paste
I
it
just-
into an Excel? Is that what you did?
yeah.
I just never download the things from so.
Okay, so finding the probability that a randomly selected professional baseball player will have a batting average greater than 0.335.
Okay. So you used the z-score again?
Yeah, but I got that wrong.
Okay. So how did they do it? What number is that? That's number 2.
Yeah.
I'm gonna open up
The
the.
probability that a randomly selected professional player will have a batting average that is greater is, and that is 0.015. What did you get?
The wrong answer. 0.930.
Okay, so
So
maybe you don't use the z-score. Maybe you. Okay. Maybe I should actually look up. There it is. Baseball batting average. I'm supposed to look at this. Suppose we want to estimate
Yeah,
the
I was actually
probability
curious
that
how to
randomly
get
selected
this one.
player will have a batting average that is greater than.
well, it's probably under 3 in the chapter, like the normal probability computations.
It's right here. It's under, yeah, it's under number 2 actually. Because it's asking the exact same question. Average that is greater than 0.28. One way to do this would be to find the proportion of players in the data set with the batting average above. We could do this by finding the number of players who fall in each of the red colors. Color bins, and then dividing this number by the total number. Okay. Got it. So what they're saying is so the question is the probability that a randomly selected professional baseball player batting average is
So we probably
greater
use
than
the probability.
0.335. Is there a graph in
Athlete.
the homework? Or in this prep questions that we're asking right now?
Like in the preparation assignment?
Yeah.
No.
Really? Frick.
I
Wow.
mean, does that one go off the information that you downloaded?
This one shows
from
a
the
graph,
Excel?
but maybe it's not.
Or do we use that?
I think we're going to use the applet thing.
Is it that thing that you can adjust the bottoms to?
Yeah, find the probability that randomly selected baseball player will have a batting average that is greater than 0.335.
Okay.
So finding the probability of stuff like this is...
Oh, you use that?
Yeah, they give us something on there.
Converting a z-score into probability easy.
You think it's the normal probability, applet?
Randomly selected.
I think it was easy. Yeah. I'm kind of curious.
Probability. Well, I mean, like, this is where the videos really come in handy. For the class, like the homework preparation videos or whatever. Yeah, because, like, it's probably in this video right here.
You're doing with the tutorial one?
Yeah, I'll just like
part 2.
Yeah, converting z-score to probability. I don't know why this is taking a year. Hold on.
Hello, this is Billy from our finance department, and this is a continuation of lesson 5. And so now we're going to compare scores or z-scores across different distributions. Here's an example of dealing with batting averages in baseball. These 4 baseball players took ranks in 1941, Rod Carew, and I believe 1977. George Brett and
That's still not what we want.
Z-score for 10 points was 0.3788. Was a very high score. It's about
Yeah, it is.
shots.
So I wonder if it's just converting this problem into the z-score and then putting it into this. It's like basically exactly what he's doing here, because he's gonna take the z-score, put it on this thing.
So what you did is you found the z-score, but you didn't put it into the thing?
I don't know. That's what I'm thinking.
Higher score, so to speak. Quote unquote higher score. Okay, so now what I'd like to do is I'd like to talk about converting z-score to probability. Okay.
Yeah.
So there are 2 different steps of taking the z-score to probability. First, we get a z-score. That's step 1. Convert the value of x using the standard normal variables to find the z.
So we should have first step. It's greater than 3.35. Okay, so but it's greater than, like that's different than just plugging in the value, isn't it?
No,
Because like in this problem, we just took the 0.19 and we plugged it into the equation. But greater than is talking about, okay, on this point in the map, all the way up.
Higher.
Yeah, so it's like, you find the z-score of this right here. I wonder, because if you find the z-score of that right there and then higher, I just don't know how we get the higher. But maybe that's where the applet
So
comes in.
it says here. It says we can do this by finding the number of players who fall into each of it. Okay, we'll be batting average that's greater. One way to do this is by finding the proportion of
Was
players
something
in the data set who have batting average above this. We can do this by finding the number of players who fall.
This is kind of like how they did it right there too. Like,
Hmm.
no, I know at the bottom they were talking about how we could find out the where's it? Right here.
The thing is, like here, it has a graph, so we kind of like know what's going on. But
Yeah,
this, they just have a.
because they turn that graph into this, because you see how they take out any part that's outside of the.
Yeah, but we don't even know how many players there are.
I don't think you have to know.
Really?
Yeah, because then down here is where they go back to it and figure it out right here. And they never mention anything about how many players there are. It's just the mean, the standard deviation, and then they use that to get the z-score. And then they use this with the z-score to find out the area above the average, or the what's it called? Their batting average of 33%.
Yeah.
So we have to know the z-score and use it with this thing,
So that would be fine.
the applet or whatever it's called.
Okay, so if they're batting average, if we're still using the same data, which I imagine we are, right?
Mm-hmm.
Then this is the mean. This is the standard.
So your answer for the last one, I think it will use the same exact answer.
What's throwing me off is average that is greater than. So I just don't think we can do the pure like point or like. I don't think this is right, but I guess
So
we could see if it is.
What did we find the z-score for before?
It was just the other problem up here. Just these.
Okay, so
Well, I mean, okay, so then 0.335. I mean, that should be the right z-score then.
right,
Or
yeah.
like if that's correct, which I don't think it is because of the average that is greater than. But if we take
So it says that you want to find everything that's above it. So what you would do is you would. I don't freaking know. It was saying something about like.
so do we do that? Maybe that's right.
Maybe.
So yeah, that's what I just got too.
Because yeah, just plugging that z-score in and then
Because
is this the probability? The area is not the probability, is it?
No. Well, the blue.
What is the area?
Well, let's see. Is 0.015 is the correct answer? Is there a way to get 0.015 from this?
I'm gonna type. Let's see. 0.
Oh yeah, reverse engineering.
That's still the. I don't even know how.
Get
That's not
2.4.
close to the answer that it is that you got for the.
Oh, this one?
Yeah.
Yeah, because that one was actually right. 2.176 is.
Wait, so maybe what they're saying is, for example, we know that. So what does this score mean exactly?
It's just how
It's
far
how
away they
many-
are from the standard deviation, how many
standard deviations they are away
like-
from the mean.
so it'd be, there's 0, then you'd be 2 away. So it's
Gotcha.
either that 2 or just 2.
Because I'm almost wondering if what we should do is just go back and reread the chapter or watch through the videos and kind of work through these things and then come back together. But I'm just wondering if there's just more that we need to really take out of the chapter.
I mean,
Did you read everything?
I read everything and I
It still didn't work.
did not understand that part of it.